Everyone, I am Aditya, and today we are going to talk about image sensing and acquisition in digital image processing. So let's proceed to the introduction. Image in which we are interested are generated by the combination of an illumination source and the reflection or absorption of energy from that source by the elements of the scene being imaged. The illumination may originate from a source of electromagnetic energy such as radar, infrared, or X ray energy. Illumination energy is reflected from or transmitted through objects. An example is the first category is light reflected from a planar surface. Incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is responsive to the particular type of energy being detected. The output voltage waveform is the response of the sensor, and a digital quantity is obtained from each sensor by digitizing its response. So, in this section, we'll look at the principal modalities for image sensing and generation. Principal sensor arrangement used to transform illumination energy into digital images. They are as single image sensor, line image sensor, and array sensor. The incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is responsive to the particular type of energy being detected. The output voltage waveform is the response of the sensor, and a digital quantity is obtained from each sensor by digitizing its response. Now, we have, and here I have a line sensor and an array sensor. In the line sensor, you can see that the energy falls and it filters and goes into the sensing material. There is a power inlet, a housing, and the output is in a voltage waveform. So let's go deep. Image acquisition using a single sensor. So let's take an example of a single sensor that is a photodiode. Now, to obtain a 2D image using a single sensor, the motion should be in both x and y direction. The rotation provides motion in one direction. The linear motion provides motion in the perpendicular direction. As you can see here in the diagram, this is an inexpensive method and we can obtain high resolution image with high precision. Now, let's go to using a line sensor, that is sensor strips. The sensor strip provides imaging in one direction. Motion perpendicular to the strip provides imaging in the other direction. Image acquisition using and thus individual sensors are arranged in the form of a 2D array. The type of arrangements is found in digital camera. Example like a CCD array. In this In this, the response of each sensor is proportional to the integral of the light energy projected onto the surface of the sensor. Noise reduction is achieved by letting the sensor integrate the input light signal over minutes or even hours. The advantage of using image acquisition using an array sensor is since the sensor array is in 2D, a complete image can be obtained by focusing the energy pattern onto the surface of the array. We can see that we have displayed an example of a digital image using an array sensor. So first we have an illumination source, that is our energy source, and then our scene material, the illumination is lighted onto the scene element passing through the imaging system. Now, all this happens, and the imaging system projects it on an image plane. And inside, we later obtain a output image that is digitalized. So, the sensor array is coincident with the focal plane. It produces an output proportional to the integral of light received at each sensor. Simple image formation model. Images are 2D dimensional functions of the form f of x comma y. The value or amplitude of f at spatial coordinate is a positive scalar quantity. When an image is generated from a physical process, its intensity values are proportional to energy radiated by a physical source. As a consequence, f of xy must be non-zero and finite. That is, it should lie between the range of 0 to infinity. Hence, f of x comma y should lie between the range of 0 to infinity and should not be a negative value.